Alright, so here are the power questions that we're going to review. We just talked about power, its formula, how it relates to work. So the first question says, two physics students are weightlifting. Will lifts a 100-pound barbell over his head 10 times in 1 minute. Ben lifts a 100-pound barbell over his head 10 times in 10 seconds. Which student does the most work? So again, when we look at work is going to be force times distance. So you need to ask yourself, did they use the same amount of force, and did they go the same distance? So the force they used was a 100-pound barbell. So yes, they used the same force, and they went over their head. So we're assuming it's about the same distance. So they both did the same. Which delivered the most power? And again, power is going to be work divided by time. So it's the rate at which work is done. And again, if in order to be the most powerful, you want to do a lot of work in the shortest amount of time. So looking at the question, it says that Will did his in 1 minute and Ben did his in 10 seconds. So we're going to say Ben was the most powerful because he did his in a shorter amount of time. Number 2, during a physics lab, Jack and Jill ran up a hill. Jack is twice as massive as Jill, yet Jill ascended the same distance in half the time. Who did the most work? So this looks very similar to a practice question we did in the notes. Like we said, work is going to be looking at force times distance. Since it says that Jack is twice as massive as Jill, Jack is going to be using more force, and they did the same distance. So Jack is going to be the one who did more work. Oh, sorry. Jack is the one. Who delivered the most power? Again, power is going to be looking at work divided by time. And this one's a bit tricky. So Jack did more work, but it says that Jill did it in half the time. So if she did it in half the time, she makes up for the fact that she is not doing as much work. So they actually did the same amount of power. Again, because Jill did half as much work, but did half as much work in half the amount of time. So they cancel out each other, making power be the same. 3, a tired squirrel that has a mass of 1 kilogram does a push-up that is approximately 5 centimeters in order to do 0.5 joules of work. And he did this in 2 seconds. Determine the power. So looking at power, we're going to need our work and we're going to need our time. Work is measured in joules, so it's going to be that 0.5 divided by our time, which is 2 seconds. 0.5 divided by 2 is going to be 0.25 watts, and that is going to be your answer. Number 4, when doing a chin-up in physics, a student lifts her 42 kilogram body a distance of 0.25 meters in 2 seconds. What is the power delivered by the student's biceps? So for this one, we're again looking for power, which is work divided by time. They do not give us the work in joules, so we're going to have to find it. The work is going to be mass. And if they give us mass, we're going to have to find the force of the object. So the mass is 42 kilograms multiplied by 9.8. And that's going to be 411.6 newtons. And then our distance would be that 0.25. So we're going to multiply those two together to get the total work, which is going to be 102.9 joules. So again, we had to find the object's force, which is their mass times gravity, to get 411 newtons. And then we're going to multiply that by the distance it traveled to get the total work. once we have that, we're going to plug it into the power formula. And the time they gave us was that 2 seconds. Divide that by 2, and it's 51.5 watts. And that is going to be your answer. And then finally, looking at number 5, an escalator is used to move 20 passengers every minute for the from the first floor to the second. The second floor is 5.2 meters above the floor. The average passenger has a mass of 54.9. Determine the power in order to move these passengers in this amount of time. And that's going to be every minute, so 60 seconds. So our time is 60 seconds. Our distance is 5.2 meters. And then they give us the mass of an average person. So the best, and they say 20 passengers. The best way to solve this is to find out how much work is needed to do one passenger, and then just multiply that by 20. So the first thing we need to do is find that work in order to find power. So work, again, is force times distance. They do not give us the force, so we need to find that. And again, that's mass times gravity. So the mass they give you is 54.9 kilograms. Gravity is 9.8. We're going to multiply that together. To get 538.02, and again that's our force, so we're going to plug it in over here. We're going to multiply that by our distance, which they give us is 5.2. Multiply those together and we'll get 2,798 joules. So that is the amount of work needed to lift one passenger up that distance. And now we need to find the power. So power is going to be that work divided by the time they gave us, which was that 1 minute. So divide that. So that's the work needed for one passenger, and you're going to multiply that by the amount of passengers, which was that 20. So multiply that by 20, and you're going to get your answer to be 932.67 watts. So that is the amount of power needed to lift 20 passengers. And that is the worksheet. Or sorry, that's the power worksheet. That's it.